Hello friends, today we solve problem on uniform acceleration motion. So let's see the problem. Problem on uniform acceleration motion. Question: a halogen gas filled with the balloon which released from a ground travels vertically up with the constant acceleration of 2 meter per second square. The 3 seconds later, a stone is projected vertically up from the ground to hit the ascending balloon. The stone just managed to touch the balloon at the peak of the path. Find the velocity with which stone was projected and the height at which stone touches the balloon. So here in this question, two particles or two bodies are involved. First body is a balloon and second body is a stone. Okay, in question they mention the balloon is filled with the halogen gas and released from the ground, travels vertically up with the constant acceleration of 2 meter per second square. So the motion of the balloon is a uniform acceleration motion. The second body is a stone. Okay, after 3 seconds later, a stone is projected vertically up from the ground to hit the ascending balloon. Means stone is under gravity, motion under the gravity and moving vertically upward. The stone is just managed to touch the balloon at the peak of the path. So if we throw a stone in upward direction, it is work against the gravity, means the acceleration on the stone will be negative value of gravitational acceleration, that is 9.81. It is a deceleration motion. The acceleration on the body goes on decreasing after every second. At a particular time, the acceleration of the particle becomes zero, and that time the height or the displacement achieved by the stone is a maximum height. At that point, the final velocity of the stone is zero, and they mention stone just managed to touch the balloon at the peak of the path. Means at the peak of the path, the final velocity of stone is zero, and they ask to calculate the velocity with which stone is projected and height at which stone touches the balloon. So let's first draw the diagram. This is a ground level. This is a balloon. Okay, it is a stone. Stone is projected in upward direction and balloon also projected in a release from the ground and moving in upward direction with the acceleration 2 meter per second square. Okay, balloon B and stone. So in this question two bodies are involved, so we have to consider origin first. So I consider ground as a origin level. Okay, balloon is at position 1. They mention stone just touches the balloon. Okay, and we have to calculate the velocity with which stone is projected, u, and the height at which stone touches the balloon, h. And this height is maximum height because they mention stone just managed to touch the balloon at peak of the path, and this stone is under motion under gravity but in deceleration motion, and the deceleration motion and acceleration of stone goes on decreasing, and at a particular point their final velocity becomes zero, and this h is the maximum height that achieved by the stone. Okay, so let's solve this problem. So first we consider the motion of balloon from origin to position 1. So it is a uniform acceleration motion. So initial velocity of balloon B is 0 because balloon is released from the ground. Final velocity of balloon not required. Distance traveled by balloon or displacement of balloon is h meter, and time required to reach the balloon at h is t1. Let's consider t1 second, and is a uniform acceleration motion, and acceleration of the balloon is given in a question, that is 2 meter per second square. Okay, so here we know the value of initial velocity, we know the distance or displacement of the balloon, we know the time required for balloon to reach at that position 1, and the acceleration of the balloon. So according to Newton's motion equation, S is equal to ut plus half at square. Okay, so here S is h, initial velocity of balloon is 0. Okay, half into acceleration of balloon is 2 meter per second, and time required for balloon to reach the position 1 is t1 seconds. So we get first equation, h is equal to t1 square, equation number 1. Okay, now consider motion of stone. The motion of stone is a motion under gravity and it is projected vertically up, therefore it is against the gravity. We take sign convention negative. Okay, given initial velocity of stone A, we have to calculate initial velocity. Final velocity of the stone A is 0 meter per second, because in question they mention the stone just managed to touch the balloon at the peak of the path. At the peak of the path means it is a deceleration motion, and deceleration motion and acceleration of stone goes on decreasing, and particular point the final velocity of stone becomes 0. At that position stone then moves under the gravity and comes on the ground. Okay, here acceleration of A is negative 9.81 meter per second square. Okay, displacement of stone A is h meter, and time required for A is t1 minus 3 seconds, because they mention after 3 seconds stone is projected vertically up. Means if the balloon is in motion for t1 seconds, then stone is in motion for t1 minus 3 seconds. Okay, so we have to calculate the velocity with which stone was projected and height at which stone touches the balloon. So we have to calculate UA and H. Okay, so according to Newton's motion equation, okay, S is equal to ut plus half at square. So we know the value of S, it is h. Initial velocity is to be calculated UA. Time required is t1 minus 3 seconds plus half into acceleration is minus 9.81. Okay, and t is t1 minus 3 square. Okay, so here we get the second equation number 2. We get the first equation, that is h is equal to t1 square. H is equal to t1 square. We get the second equation, h is equal to ua t1 minus 3 plus half into minus 9.81 into t1 minus 3 square. Here three unknown. There are three unknown. First is the h, second is the ua, initial velocity of stone, another one is ta, and we have just two equation number 1 and equation number 2. Here is a three unknown, so we also require three equation. So let's consider third equation. Third equation is v is equal to u plus a. Okay, we know the final velocity of stone A. We know the final velocity of stone A, that is 0 meter per second. Okay, we have to calculate the initial velocity of stone A. So consider as it is. We know the acceleration of stone A, which is against the gravity. So we take minus 9.81. And TA is T1 minus 3. Okay, so we get UA is equal to 9.81 into T1 minus 3. Okay, T1 minus 3. So we get third equation number 3. If I substitute equation number 3 in equation number 2, so from equation 2 and 3, so we get h is equal to 9.81 into T1 minus 3 into T1 minus 3 plus half into minus 9.81 into T1 minus 3 square. Okay, if we solve this equation, we also know h is equal to T1 square from equation 1. Okay, so we get T1 square is equal to 9.81 square minus half into 9.81 T1 minus 3 square. Okay, if we solve this equation, if we solve this, here there is one unknown only, T1. If we solve this equation, we get equation 0 is equal to it is a quadratic equation, so we get two values. T1 is equal to 2.066 seconds or T1 is equal to 5.469969 seconds. T1 is a time required for the balloon B to reach at a position 1, which is 2.006 seconds or 5.4696 seconds. But they mention after 3 seconds, in question they mention after 3 seconds stone is projected. So 2.066 seconds is not possible. Okay, so we get the value of T1, that is 5.4696 seconds. But we have to calculate initial velocity of the stone and the height at which stone touches the balloon. So we have to calculate UA and H from equation 1. H is equal to T1 square. H is equal to T1 square. So H is equal to 5.4696 square. H is equal to 29.91 meters. This is our first unknown value. From equation 3, u is equal to 9.81. From equation 3, we get the value of initial velocity of stone. We get the final initial velocity of stone A, that is 24.22 meter per. This is our final answer. Okay, so the velocity with which stone was projected, the answer is 24.22 meter per second, and the height at which stone touches the balloon is 29.91 meter. That's our final answer. Thank you. If you find my videos are helpful, then please like, share and subscribe our channel. Thank you.